Let's move to the next section, which is about force between two wires. So we have two wires here. There is a current circulating in this two wire. Each of them will generate a magnetic field. So, but we saw in previous chapter, if there is a magnetic field and there is a wire, well, this wire will feel a force. So, is there a force between these two wires? So let me here show you a video. So in this video, you see that there is a current circulating in these two wires. So if these two wires are connected in series, okay, so you need to remember circuit or current and circuit chapter. So these two wires are connected in series. It means that the current is flowing like this. It go maybe through a battery and it come back to this wire. So how is the circulation of the current? Well, the current here is upward, let's say, and the current will be downward. So these two currents, they have opposite direction. If we turn the switch on, if we close the switch and there is a current flowing, you will see that these two wires are repelling each other. However, in parallel situation, if these two wires are connected in parallel, so you need to remember circuits, so if these two wires are in parallel, it means that the current, they are parallel, they are in the same direction, they are moving in the same direction. Okay, so if the current are moving in the same direction, what we will have? We have an attraction. These two wires will attract each other. I share with you the link for this video. So that's the rule. Two wires are parallel. We need the current are circulating in the same direction. Generally, we call it parallel current. The two wires will attract. Okay. If the two currents are moving in opposite direction, so we call them sometimes anti-parallel current, the wire repel each other. So we have a demonstration and we know the rule. Now, how we can get a theoretical founding of this observation and how we can calculate this force. So there is a force, there is an attractive force, there is a repulsive force. How we can calculate the magnitude of this force. So basically we have two wires here, two parallel wires, and there is a force between them. So how to calculate this force? So here we have a schematic of these two wires, parallel, very long wire, separated by distance d. And there are two currents circulating in these two wires, I1 and I2. Let's say we have a current carrying wire, current I1. This current will generate a magnetic field everywhere in the space. So at this point, there is a magnetic field created by this current. At this point, there is a magnetic field created by the same current. At this point, well, there is still a magnetic field created by the current one. Okay? Remember, field lines are circulating the wire. So at this point, there is a magnetic field strength. What is the magnetic field strength? So first of all, what is the direction of this field? Well, the current is pointing upward. The two currents, by the way, they are pointing upward, so we have a situation of parallel current moving in same direction. So if you put your thumb in direction of current 1, your finger will point into the board. Okay, so you need to train yourself on right-hand rule. So B1 is into the board. What is the strength of this field? Well, we just saw it. B1 is mu0 I1 over 2 pi the perpendicular distance d. What you notice? At each point from the wire 2, the strength of B1 is the same. Alright, so B1 vector is not a uniform field, but at each point from this wire, B1 is constant. So if you remember chapter 39, we have a wire, current circulating in this wire, and this wire feel another field, B1, which is uniform. For him it's uniform. For this wire, B1 is constant along this wire. So there is a force acting on this wire, F2, 1. How I calculate it? From that's the current circulating, I2, L cross B, which B, B1. So you have a wire 2 in a region of a magnetic field, B1. That's the formula, right? So if you apply now for direction right-hand rule, L is in direction of current, so L, I to L, cross B1. I to L, you put your hand in direction of L, on direction of current 2, and you rotate them, you sweep your finger in direction of B, you will see that your thumb is in the left direction. Okay? So again, here we apply right-hand rule of previous chapter. So you put your hand in direction of L. So let me draw L for you. That's L. Okay? Direction of L. You put your hand in direction of L. Your finger are pointing in direction of L. You sweep them, you rotate them in direction of B, so you rotate them into the board. You will see that your thumb is pointing to the left. So that's the force. So indeed there is an attractive force. Now what is the magnitude of this attractive force? Well, F21, it's current 2, L. So what is L, by the way? That's just any length from this current 2. You take any piece from this wire 2, this piece will feel a force due to wire 1. Times B1, it's mu 0 I1 over 2 pi d sine phi. What is phi? That's sine of. So you have L and B1, they are perpendicular to each other, so that's sine of 90 degrees, which is just 1. That we can write it this way, F21 equal mu 0 product of the two current over 2 pi, the distance between the two wire, times the length, the element length that you choose. So basically, that's the formula shown here in the corner. Okay, so by the way, the force per unit length, sometimes in problem we ask you to calculate the force per unit length. So the force divided by the length, that's mu 0, the product of the two current divided by 2 pi and the distance between the two wire or the two current. So let's take here a checkpoint just to see your understanding. So I will not solve it fully. So you have a 3 long straight parallel equally spaced wire with identical current. Where are these wires? Well, they are shown with this symbol. So here the wire, the current is coming toward you, is out of the board, and here you see the cross, so the current is moving into the board. Okay, so what show you the symbol? The direction of current. And these wires are spaced, let's say, with the same distance d. And is rank the wire according to the magnitude of the net force acting on each wire greatest first. So let's say if you take this wire, what is the net force acting on this wire? So there are other wires, so there are forces due to other wire, so you need to add them up. To add them up vectorially, actually. Okay? So here I will not solve this for you, I will just give you the answer. The answer, it should be, if I am not mistaken, FB greater than FC, which is greater than FA. Okay, so you need to find it, try it yourself and find it yourself. Here I will give you one example how to do things. So let's say I want to calculate the magnetic force acting on wire A. Let's say, what is FA? Vector form. So I will call this x-axis, and I will draw the different forces acting on this wire. So we just learned before that when we have two wires in the same direction, let's say A and B, they are in the same direction, what they do, these two wires will attract each other. So where is the force? The force on A due to B is in this direction. Okay, because the two wires, they are parallel current, two currents in the same direction. If you take A and C, the two currents are in opposite direction. So where is the force? These two wires will repel each other. So the force on A due to C is in opposite direction. Okay? FA, it will be equal to FAB plus FAC. So what is FAA? AB. So that's nu zero times the two current that are same current, so that's just I square over 2 pi d along what? Along I direction, plus nu zero I square over 2 pi, the distance from A to C, between A and C, that's 2d. Along what? In opposite direction of I, so we have minus I direction. Okay? So if you write it in vector form, you will get mu 0 I square over 2 pi d minus mu 0 I square over 4 pi d along I direction. And this gives you, well, nu 0 I square over 4 pi d. So that's half, that's quarter. So it gives you this. So the net current is pointing in plus x direction, and the magnitude is just this. So what you need to do, you need to do the same thing for the other two wire, and at the end you will compare the magnitude of this wire. So that's the magnitude that you need to compare. Okay, so thank you for watching. See you in my